Okay, here's the second problem. A conical shelter is to be made that is 3.2 metres high with an apex angle of 60 degrees. Calculate first the area of canvas material needed for the walls. So we're talking about kind of a teepee thing, a cone. How much material is needed to make it. And B, how close could you get to the wall before you hit your head, assuming you're, let's say, 1.6 metres tall. Okay, first thing I'm going to do for a problem like this is draw a diagram. And to begin with, it can be a pretty rough sketch. Now it's a cone. It's 3.2 metres high, so I'm assuming that will be the perpendicular height. 3.2 metres. And the apex angle up here, that's the whole angle across the top, that angle is 60 degrees. I need the area of canvas material for the walls. I'm going to need to remember the formula for the surface area of a cone. The whole thing for the cone, total surface area, is pi r squared plus pi rs. Now this bit is the bottom. I need a different colour. This bit is the base, the circle on the bottom. So this bit here is the bit I want. That's the walls. But to use that, I need the slant height and the radius. I don't have either of those things in my diagram or my problem. But I can work them out, can't I? Look at this side of that cone. Can you still see it? Yes. So if I just draw that triangle for the side there, right angle. Oh, hang on, this is 3.2 metres. What's this angle up here? Well, if 60 degrees is the whole cone, then this angle is half of that, 30 degrees. And correspondingly, if I find it easier, I can use this angle. If that's 30 and that's 90, this has to be 60 degrees. I can now choose whichever of those I wish to use. I'll move that across just a bit so you can still see that diagram a bit better. Okay. Alright, I need both the radius and the slant height. Now I can work out either one of those using trigonometry. And then I could work out the other one either with more trigonometry or I could use Pythagoras. Because having got two of those sides in a right angle, I can work out the third quite easily. I prefer rather to use trigonometry twice, and the reason is, if I make an error calculating this, at least I could still get this one right, or vice versa. Doesn't matter which order, let's do R first. Let's label these sides so we don't get too confused. That's my hypotenuse. Which of these angles will I use? Let's use the 60. I'm used to using angles of elevation and depression, which we'll get to in a moment. They're always measured from horizontal. So let's use the 60-degree angle. And so we don't get confused, I might even roll out the 30. Okay, so we don't make mistakes. If that's 60, then this is opposite, and this is adjacent. Okay, for R. For R, I've got opposite and adjacent. That's tan. Tan of my angle is opposite on adjacent. Put in what I know. Tan of 60 is 3.2 divided by R. Cross multiply. R is 3.2 divided by tan 60. Time for the calculator. 3.2 tan 6, no. 3.2 divided by tan 60 is 1 point, how many decimal places? Is metres of material. Again, I might go to millimetres. 1.848 8. It's 8475, which rounds up to 848. That's the radius inside my tent. So 1.8 metres radius, or double that for the diameter, about 3.6, 3.7. Okay, that was R. I'm going to do a very similar thing for S, the slant height. For the slant height, I've got opposite and hypotenuse. Notice I'm going back to the one I was given, not the one I just calculated. I could do it with this one, or as I said, I could use Pythagoras. I'm going to go back and use trigonometry with the original number again. So opposite and hypotenuse is sine. Sine of my angle is opposite on hypotenuse. Putting what I know, sine of 60 degrees is my opposite, 3.2, divided by my hypotenuse. What I want to know is the slant height. Again, cross multiply. S goes up the top, and sine 60 goes down the bottom. And you need a calculator. 3.2 divided by sine 60, 3.695 metres. Again, rounding off to 3 decimal places. Okay, what was I asked to find again? I've done all these calculations and I've forgotten. I had to find the area of canvas material needed for the walls, which I was going to do using this part of my formula. So, 1, 2, 3. Area is pi rs. Pi times 1.848 times 3.695. Again, if you're clever, if you've got a good calculator, you can actually keep both of these numbers and use both of them directly in this calculation rather than rounding them off. In this case, I'm going to get more accuracy than I really need, so it's okay. Pi, always use pi on the calculator, don't type a shortened version. 8, 4, and that, okay. 21.4466, and it goes on. Again, I'm not sure how much to round off. Square metres of material. I might again go for, look at this, I might again go for 3 decimal places. It's probably more than I need. This is more than 5, round that up. 447 square metres. And you've done it. That was A. B says, how close could you get to the wall before you hit your head? So you're standing here. How close can you get to the wall before you hit your head? If I go back to my triangle here, I'm standing here somewhere. I'm 1.6 metres tall, and I want to know not the radius, my eraser, not the radius, but let's call it W for wall. How close can I get to the wall before I hit my head? Okay. Let's try that. Let's rub this out. Okay, I have a small right angle triangle here. Well, it's not small, but it's smaller than the previous one. In this little right angle triangle, 1.6 high, W I want to know, 60 degrees. Trigonometry. Which rule do I need? This is the adjacent, that's the opposite. I need tangent. Tan of my angle is opposite on adjacent. Put in what I know. Tan of 60 degrees is 1.6 over W. Cross multiply. W is 1.6 over tan 60. Calculator. divided by tan 60. It's 0.9237. I probably don't need that much, do I? Meters. I reckon centimetres is good enough for how close I can get to a wall. That'd be here. This one is less, 0.92 metres. So I can get 92 centimetres away from the wall before I bump my head. That's the second problem.